Alright guys, I'm back. Anyway, I believe this will be, gotta look and see. I think this is part 4 on the Stromberg Carlson by 21. So, I want to give you a little treat here showing you how to restuff a capacitor, especially one of these electrolytics here. So he's got a cardboard tube that goes over a metal capacitor, and show you how to get that out, and some various things. At least show you how to get it apart and stuff. So I already did some of the others. I'll come up here. Oh, this guy, and this guy, and this one, all electrolytics. Already stuffed them. Did the cans. They've been restuffed. So crimped them back over. These were actually pretty easy to open up because they were pretty wide crimps. I've done these before on video, so I didn't think I needed to do another video on them. These are kind of scratched up a little bit. I'll probably polish them a little bit. That's why they're not in yet. If you polish them before you even re-crimp them back together or anything, you just get fingerprints all over them. Then you're back to repolishing again. I don't know how much I'll get carried away there underneath the chassis. We've got the tuner for the time being back in. I may pull it back out. So it's back together basically. There was like 1 or 2 resistors that were out of tolerance, so it was no big deal. I replaced those, and then on the TV, and I'm not sure where I put the part, but down through here there's a riser board I took out. It ended up being easier because it's got a lot of bad resistors on it, some of them deep down. This riser board set down in here like this, and especially on this side you got a lot of components going. Of course, all the caps need to be replaced. There's a few of these resistors that's out of tolerance, but on the board itself there was some rather, like this guy here is out of tolerance. Trying to get to it from the top down with everything in place would have been very difficult. This one's out of tolerance, that one's out of tolerance, that one's out of tolerance. So, and then plus I got a cap right here that needs to be, I guess that's just laying on there. He was down in here. Another cap here. So then on this side we've got cap, resistor out of tolerance. So I decided it would just be simpler to pull it out. Now in the process, sometimes Murphy gets in your way and things happen, but there was one of the tabs connections right here is broke off. Now I think it's been stressed already because I had just started applying heat to it with a soldering iron, and a little bit of pressure putting soldering iron on it, it just came loose. So, but I'm not really worried about that because of the simple fact that I've got some spares. Right up here is a spare one, over here is a spare one. So they're just little metal pieces here that bend over. I can shove them back in, desolder this, which I think, yeah, desolder that resistor and then just shove it back in, bend the tabs back over, and it'll be good to go. Clean it up a little bit and tin it first. So I did check so far just this guy. He was up top for leakage and capacitance. He's right on the money on the capacitance, and the leakage came excuse me, came out good. It was no leakage whatsoever, up to 500 volts. That's about the highest I can go. So it was good, and so really basically it just replaced what needs to be replaced on there. I've been checking some and started doing some work down in here. There's quite a few other resistors down in here that are checking bad. I still got a few more to check, so I'll be down in there. It just got a few. There's these wires here, hooks to it. Not this guy, but there goes the tuner. This bunch goes in here. Got a wire here, wire and wire here, and some components and stuff. Some wires down here that went to the board. So it's not that difficult to take out. It took me probably 10 minutes to get it out of there. So anyway, that's where I'm at on it. So before we start on the cap, I wanted to show you something, and I want to talk a little bit about power resistors and how they open or go bad. Wire wound ones. All wire wound resistors can go bad. But if they, I showed this one before. This is the one that burned up. It was all bubbled up right here and stuff. I bring it up here a little closer. That just happened to chip away real good, and I don't know if you can see how dark and black it's in there. It burned up the nichrome wire, which is what they use, which takes quite a bit of heat to do. I worked out the math. This basically had over 82 watts going through it. It's a 5-watt resistor, so it's no wonder that it went bad like it did, burned up. What really surprises me is I'm not sure what cotton picket ink they used, but 82 watts of heat on here, and that's why it bubbled the way it did, and that's usually what they do. But I've never seen one actually keep the writing. I don't know, this thing is being a little stubborn. That has got to be the highest temperature ink I ever seen. 82 watts is a lot of heat. So, now, their nichrome wire under normal circumstances can't be soldered to. And so, there's various techniques, ways of connecting to it. Now, I don't have an actual showing of one way of doing it per se, but I can kind of explain it. But okay, one general way of making connections is you use a piece of steel and you wrap it around, and you make a loop in your lead, that copper lead it's going to hook on, and then you run a rivet through. That rivet keeps tension on that steel. Now, one of the problems that happens with these is actually they just start having, can even open or have problems being intermittent or real high resistance, way out tolerance, is that through heat and expansion over time, these can actually open up. With the rivet in there, it kind of keeps them pretty well locked down, so they these actually stand up pretty good. But they still can get corrosion in there. And the one that I did have that really shows that good is this guy. This is a new old stock, never been used, sand ohm resistors. Just got a sand coating on it. It's supposed to be 59 ohms. This thing measured several thousand ohms. So I chipped away at the sand and got the end off because I wanted to show you the rust inside the end. This would set on here. This just clamps on. It's just, I didn't cut that. It just clamps, just bent down and held down, and then they put the glue and the sand over it to seal it up. So this would set on like this. when you first open it up, you really wouldn't have noticed too much. At first, the metal looks kind of good, but it's actually what's underneath when you open these up. So you see the rust in there, which causes quite a bit of resistance or even complete open. The biggest problem with these is over time why they do corrode is more because of the glue that the cement type material they used to hold the sand in place, and so that seemed to react kind of badly to the steel, causing it to rust. And it's over a length of time, but it don't have to be connected up. Obviously, this is new old stock, was not cut out anything. Never had ever been in circuit, and just sitting, it rusted up like that. I'm sure this ends the same way. Generally, if these burn out, they'll discolor first in the middle and then work outwards, and it'll end up just melting this and opening a hole right in here, and that's where the resistance wire will burn through. Now, another technique is, of course, the cano style. Kind of zoom in here a little bit. There we go. Is this style. Now this actually just what it is, piece of metal, steel generally, that comes in. It'll go underneath this outside piece, but it goes down, bends back around, and comes back around this way and comes over, and then that clamps on, and of course the nichrome wire runs underneath it, just the same way as this style did. But the other thing they do is they put in this insulation paper in here. It's pretty thick and pretty tough stuff material, and then they clamp the outside can over. Now these generally won't give too much troubles as far as heat goes and expansion, as long as they're well within their wattage range. If they are drawing too much current through them, something's shorted somewhere, you know, like or leaky capacitor, and it's drawing too much current, and especially if they were sized pretty close to their wattage range, then over time heat will cause this to expand enough where they'll start losing connection. But they still can corrode. Generally the corrosion on this type and you know, these type and stuff really won't happen unless they get hot, really hot. Under normal circumstances, well within their range of their wattage rating, they generally don't give too much trouble that way. What usually you will find with these is if you're measuring it and you move this back and forth a little bit and you see your measurement jump around, it's because it's been overheated and it's expanded, and now when you're moving it, you're making a little better contact and a little less contact, and that's usually what happens with those. Otherwise, if they're sized properly and there hasn't been any real leakage current going through them, you know, something leaking somewhere, drawing too much current through them, increasing the wattage, they'll stand up pretty decently. Now, another type, you know, let me zoom back out. Let's see, that's telephoto, this is wide, go back out. And I'll just kind of shift this back down a little bit here. The other type, another type is like these. Now if you notice, and of course it's Victor's enamel just like this is, but it has no rivets and no little leads coming off. What it does have, and some of these you may not notice because they're tinned with a little solder on them. This one wasn't, so it's just a piece of copper goes in here. But what they do is up in here inside, they cut that copper a little bit, make a little finger coming out. And then they'll wrap the nichrome wire around that. Then they'll use silver solder. It's usually 30 or 40% silver. It's not like your standard silver solder you might see used in like air conditioning systems, which is 5 to 10%. This is a lot higher level silver. It takes a lot more heat. But you'll use that 30 or 40% mixture of silver solder. And nichrome wire actually corrodes just a little bit. It develops a thin layer that darkens it. When it's really literally brand new coming out of the factory, it is chrome color. I mean, it's nickel chromium. But the nickel will actually develop a little bit of corrosion on it, tarnish. It's black, and it literally will not solder to. So and to get it off, they have to actually use a special acid flux. Now, it's not like a paste or a liquid flux. It's a powder that they put on there, and then when they apply the heat to it, then it flows, and it cuts that tarnish off and allows you to solder to it. Now, the reason why you could actually use regular solder, but it'll melt instantly. I mean, as soon as these things, I mean, it's depending on the wattage. Something like this size, which is probably I don't know, probably 25 watt or so, or 30 watt. It would melt that solder in a heartbeat. So the reason why they use the silver solder is not because of the nichrome as much as because of the heat. And they use pretty substantial heat, either straight flame or using a special soldering iron that gets extraordinarily hot. The problem that happens with these is they can't always get completely free of that flux off of there. And it's an acid. Now, as long as it's in its powder form, it's not active. But if it gets a little enough moisture to it, combined with heat, it becomes active. Even if it's low level heat, a few watts of heat will cause it to become active. And if there's a little bit left on there, and generally there is, that will actually it'll eventually eat through the nichrome or the copper or both. But it'll break down that connection, and these will open. If you think you got one, it's measuring open, you think it burned out. Burned out is this. Okay, that's burned out. Okay, it will bubble up and everything else and stuff. That's burned out. If it looks just fine, then it opened because of corrosion. But other than that little problem, these are actually one of a pretty darn good solution, and usually stand up pretty good. These are probably these are a decent one too, because of the clamping pressure with the rivet. But I wanted to just kind of go over those real quick, just to kind of give you a heads up on them. Are any of them bad? Any of the solutions bad? Not really, because for the contemporary time period and what they suspected them to last, they did. For the most part, most of them lasted just fine. So, this thing, the San Ohm is probably, I don't have date code on it, but my guess is, it's from the 50s or 40s. So, how long is something, should something last? So that's really what you're looking at. Now, if Murphy will behave, not throw Murphy's Law at me, and of course also I'm doing this around a tripod, we're going to try to open this cap up, and a couple times here I'll pause the video, but to get other things ready. But the tool I'm going to use is a spoon, what they call a soldering spoon. You get these with a set of soldering tools that you can pick up. I think even Mauser carries them, and stuff. A lot of times you see these around quite a bit. Brush on one end, some sort of spade on the other end, either flat or straight across or angled. These are used, of course, the brushes are for cleaning. These are used to unhook hooks or loops of wire, around terminal strips or something. You stick the wire in and wrap around and solder it. Well, this will get in there and pry against it and open it up. Various other tools. It's called a reamer tool. It just, one end is kind of flat all the way around, the other end is smooth. Just to clean out holes or even ream a little bit. The spoon, which what I'll be using with the capacitor, has, I don't know if you can see that, but it has on this end, which will be the end I'll use. It's a little flat area that's bent a little bit. This is a little different. Kind of step over. These are actually for popping off surface mount components, like small components like your passives and stuff. And then there's hooks, just for various different things that you need to hook stuff. Hook onto a wire and pull it loose or something, or get a hold of it or whatever. Two different types of ends and so on. Sets of those are not real expensive, and they're nice to have, kind of handy. But we're going to try now. The first thing I do with these is I inspect the end. Usually one end looks a little better because basically this is curved over, so it's kind of like that, and I need to get underneath one point of it and then start opening it up. So I'm going to look at and try to figure out which end. Sometimes this end's easier, sometimes this end's easier. So we're going to really, on this, it doesn't make too much difference which end to do in any case. So hopefully this will stay in the camera, because I need not to look through the camera. Hardest part is trying to get them started. Now you'll rip a little paper, but you need to get completely underneath there. And then what you do is you just kind of rock it, keep it tight, and keep your finger against here so it don't poke through. And keep it tight, and just keep working it around. And they'll just open up real nicely. Sometimes wiggling a little bit will help. And sometimes they come out. But that spoon is not sharp, not real sharp. If you're using the pointer, now you get it fully open like this. Sometimes I'll take my fingers in there and just kind of work it around. The other route is I can take the spoon, stick it down between here, kind of rock it back and forth. What I'm trying to do is open this up even a little more, so it's a little easier to pop out. So far Murphy's being kind of nice. All the others went real nicely, and this one is too, but I kind of figured, well, when I make a video one, both trying to think to make sure I'm in the video still, as well as working around the tripod, that Murphy would really show his head. But maybe he took a vacation this week, I don't know. If anybody don't know what I'm talking about, there's an old adage called Murphy's Law that basically says that if anything can go wrong, it will. So then I usually take like some neat little pliers, because something like this you can't really get your finger in. Bigger ones you can get your finger in, and just give her a shove, and she comes right out. Now it's all opened up. I will take my fingers and kind of spread that out a little bit. This one looks like it's wanting to come unglued here. When I'm done and put this thing back together and put it back over, I will be taking, this is just some paraffin wax, and I take the soldering iron and just kind of melt it, and it'll just melt down in there, and I kind of blow it around that just to kind of reseal it or hold it tight so it doesn't reopen. Now there's a couple ways to open these. Well, many ways. You can use a Dremel tool with a cut-off wheel and cut them open. You can use a utility knife and rock them. Or if you got a tubing cutter, you can use that. Now, the biggest thing about the tubing cutter is, for one thing, you got to make sure you've got, you know, something you can hold on to and rotate it around. The other thing too is you got to keep it as straight as possible in this tubing cutter, otherwise it will actually walk with the tubing cutter. Hopefully this one will open big enough. I've got a bigger one. This is going to be a little tight, but I think it'll get in there. So I'm going to keep it down towards this end a little bit. What I mean by walk is it'll actually look like it's cutting threads. So you don't tighten it too tight, because you need to be able to turn it. And the reason they walk is if it's not completely square in there as you're turning it, it will just do that, walk. It'll start coming off at an angle. And I rotate it back and forth and stuff. So I'm going to pause the video here. You kind of get the idea, and when I come back, I've had this cut through. Okay, we got a cut open, the tubing cutter. So this is what you get. Okay, so I'm going to reach down in here as best I can with some snips and cut that off. Which in these small ones is kind of hard to do. It's reach in there and see if I can kind of just twist it around and finish it off. There we go. That's kind of the inside of one there. Now the other end is a little more, well, I've got it closer to the end. So there's a cardboard here, or actually it's a paper. So I'm going to see if I can get behind it and cut it, and just kind of break it loose. There we go. And that's your cap right there. Now this is a 5 microfarad. Throw that away and stuff. Cap. Now we're going to attempt to, we'll end up drilling a hole probably through the center rivet. Generally it works. And I'll bring my lead up and tie it over to the capacitor, the old capacitor's lead. Now the reason why I do that is, well, there's the new capacitor lead right there. Compare it to the old capacitor lead, and I hope you can see that there's drastic difference in size. This will actually hold it in better than this flimsy lead will, so we'll see what I can do. I'll try to drill it. I don't know how well this will work on camera. But I usually take, since I don't have a lot to hold on to there, I will locate my pliers and take a pair of pliers and hold on to it. Where my other pliers are. They seem to have disappeared. So it's aluminum rivet, so it don't drill too hard, but I did have one that actually for some reason just completely broke loose, so we'll see how well this works. see a little hole through there. So now the other end, yeah, I might be able to get onto it. A lot of times, generally on these, I usually like just kind of drilling off to the side, because some of these are long enough, the drill bit's not long enough to get down in there through the rivet. So this one I probably could, but we'll do it this way. And another nice hole. Now, the next step then is to put your capacitor in. Now, you're not going to have too much trouble with these. Just make sure you get them in the right way. So I always I just bought radio lead caps, which means the two leads come out the end. And but I have to solder on a little extra, so that's what I did here. We just run this in, flip these down, just to kind of keep it from ever shorting, which is usually not a problem because I hold it back a little bit. Bend this up, so I'm going to hold it back a little bit, then wrap this around. Okay. Couple turns, shove her down. So that's basically what we're doing here. Now the other end, thread it through the hole. Let me get it started here. So basically that's what I'm doing there. Bring her up, I'll pull this insulation back, and just again same thing. Wrap her around a few turns, push it down. I like clamping it a little bit, and clamp this one just a little bit. Okay, now we'll add a little solder to it. If it doesn't roll around too much. Sometimes these are kind of a pain in the butt and want to roll around on you, so I usually bring some stuff up around them. There we go. Now remember, this end here is connected to that can. It's aluminum, transfers a lot of heat, so it's kind of warm. Now what I'm going to do is go ahead and get in here and snip off what's left. Of the leads. And we're good to go. Now, we want to go back to this. And I'm just squeezing it together so that and kind of pulling it out, so that it will go in really nicely. Not too much problem anyway. The hardest part is right here. Yeah, it went in. Now I'll just take and push her down. Now what I do is start just using my fingers, kind of pushing it in here, making the rollover, getting it started. I'm not interested in what it looks like at this point, because I'm going to take the pliers, and hopefully you can see that, and just start working it around. at a little bit of an angle, so re-crimping it. Now the last little thing here is I'm going to set it, kind of bend that up, and just kind of set it in there so it has some place to hold. And a little bit of this is still wanting to be a little bit stubborn. This actually has got a little wax in it already. That's what actually held the crimp to start with. Now we're just going to try to heat the wax and hold it over that. This one's kind of a small target. I'm going to start over this way. And then I usually just kind of get it to roll around. And it's soaking a little bit there. Let it cool down. And when it gets cool, you can actually finish kind of crimping a little bit. Now you got a little more wax on there that you can kind of dress her up a little bit if you want. That's it. That's all you do to get one of these in there. And it don't really look too bad. Once that wax fully cools down, it'll lighten up. And this little guy goes down in here. He fits right down in here. Well, actually, turn over. This end goes ground. This comes around to this tube here. It's part of the ratio detector. That was the last of the electrolytics. So, I really don't think I've got a whole lot else to talk about at this point anyway. I will continue on replacing stuff and everything. So, if you like the video and everything, give it a big thumbs up. And I want to thank you for watching and your comments. And I'll get you on the next video.